Hello, welcome to the 2025 ASHRAE Competition Design Team video presentation. Each year, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE, proposes a design challenge for student teams to design an HVAC system, that is, a heating, ventilation, and air conditioning system for a hypothetical building that is to be constructed. This year, the design location is Manchester in the United Kingdom. The design team is tasked with learning and applying ASHRAE standards to the build of the HVAC system. The ultimate goals of the project being a complete model of the heat gains and losses of the architecture of the building, as well as a method for selecting the optimal system to service the building due to these needs. A series of mechanical drawings outlining ductwork, equipment, and piping if need be, as well as a full report outlining compliance with the ASHRAE standards of the selected system and design. The first step is to determine these heat gains and losses in the building. To do this, the team uses the provided ASHRAE architecture drawings of the building that includes construction materials and construction envelope. Building off of these, the team creates models in Carrier's proprietary hourly analysis program, or HAP. HAP makes use of the building architecture, local weather data, building location, as well as applied data inputs such as heat gains through intended occupancy of the building and heat gained from lighting and other electrical equipment within the building to provide a series of reports that detail the amount of power it would take to cool or heat the building during any time of the year, as well as peak load times throughout the year, ultimately compiling the size of equipment needed in tons. From here, the team must select 3 HVAC systems from a catalog of existing systems and select the best one to fit the needs of the building. The 3 types from which will be selected are a direct expansion rooftop unit, or RTU, a variable refrigerant flow unit, or VRF, and a water-to-air heat exchange chiller. Each of these systems is a heat pump unit, meaning that they use reverse refrigerant flow to create heat, as opposed to burning fossil fuels. This is a good way to keep ASHRAE decarbonization incentives in mind as the team works on their design. Per the project requirements, the system is meant to serve the building for its life of 30 years. The only equipment that will make a 30-year lifetime would be the water-to-air chiller, whereas the other 2 have a lower lifespan and would have to be replaced at least once within the building's 30-year life. Secondly, cost. As mentioned previously, because only one system is capable of meeting the 30-year life, the other 2 systems would have to be replaced, and thus recurring the initial installation and equipment cost of those 2 systems at least once each throughout the 30-year life. A cost analysis showed that the most efficient system in terms of power draw was the water-to-air chiller. Despite its initial large installation and equipment cost, it actually turns out to be the most economical choice after 30 years. Therefore, the team chose to use a chiller to service this building. Having selected a system, the team used Autodesk Revit to draft mechanical drawings of the ductwork and hydronic piping layout for the chiller system. This set of mechanical drawings, the cost analysis, the ASHRAE compliance reports, the sustainability research, and the heat load analysis are submitted to ASHRAE for the competition. Thus, this project provides an overall experience of the HVAC design process, from beginning to end. Thank you for watching this presentation.